Hello students, welcome back to another session on electromagnetic waves. So in today's class we will be moving from vector basics to actual subject where we will start with the Coulomb's law and electric field intensity. Today's content is discussing about the experimental law of Coulomb and will describe or represent Coulomb's law in vector form. Also we'll come to know how to calculate the force due to multiple charges, and we'll solve some one or two problems regarding Coulomb's law. So starting with experimental law of Coulomb. Experimental law of Coulomb. So we know that the term electricity or the concept of electricity or static electricity is day back to 600 BC, where they were doing experiments with the amber or glass or such materials. They're rubbing amber on their sleeves, and they came to know some attractive forces produced. Actually, the term electricity is derived from Greek word for amber. Electricity is derived from the word for amber, Greek word for amber. So there it comes. So later on, the experiments were conducted on sulfur, glass, rubber, or such materials. Even now, also in lower classes, you might have studied rubbing a comb on dry hair will produce static electricity. So such things they were not quantified. So later, once the Newton's gravitational law, which was stating like the force between two mass-free objects, or the object having mass is proportional to the mass of the first one, and force is proportional to the mass of the second, and force is inversely proportional to the square of the distance between them, and it is proportional to m1 m2 divided by r square, or F is equal to m1 m2 g into m1 m2 divided by r square, where g is the constant, proportionality constant, to remove this proportional to make this proportional to equality sign. So similarly, after 100 years later, one century later, Coulomb also did some experiments on charges, and he also found that there is a same relation between charges. That is, if two charge particles q1 and q2 are kept with the charge, either they can be positive, or both will be positive, or either one is positive, another one is negative, or both are negative. If two charges are separated by a distance r, let me represent it in capital R, since we are using small r for as a coordinate system. So I am representing it as capital R. So they are separated by distance r, and Coulomb stated that the force between the q1 and q2 is proportional to q1, and it is also proportional to q2, magnitude of q1, magnitude of q2. If you increase any one of the charge, the force increases, and it is inversely proportional to the square of the distance between them. So if you increase the distance between q1 and q2, force reduces, inversely proportional to the square of the distance. And similar way of Newton's equation, you can derive an equation where F is proportional to q1 q2 divided by r square. Okay. Or you can say F is equal to a constant into q1 q2 divided by r square. So this representation, F is equal to k into q1 q2 divided by r square, by doing several experiments he calculated the value of k by doing the experiment. That is why it is called the experimental law of Coulomb. So the value of k is obtained as k is equal to 1 by 4 pi epsilon 0. So this epsilon 0 is called the permittivity of free space. permittivity of free space, and the value of epsilon 0 is 8.854 into 10 raised to minus 12, and the value of this can be approximately written as 1 by 36 pi into 10 raised to minus 9. This is not exact value, but it can be approximated. It is a very good approximation, 1 by 36 pi into 10 raised to minus 9, and the unit of this one is farad per meter. Okay, no farad, it is the unit of capacitance, right? So using this, so we can write that F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. For the time being, or in our study, we will be discussing only about free space or air. We are not discussing about other materials, so we will always stick with the epsilon 0. If any other than air or vacuum medium is there, we have to represent this equation as 1 by 4 pi epsilon into Q1 Q2 divided by R square, where epsilon is the permittivity of the material which we are using, where it also can be represented as 1 by 4 pi epsilon 0 epsilon r, where epsilon r is the relative permittivity Q1 Q2 divided by R square, because we know this value 1 by 4 pi epsilon 0. If you know that one, only epsilon r you have to introduce. That is why this is the simple notation for any other medium, but most of the cases we will be discussing about air or vacuum. So what is the value of 1 by 4 pi epsilon, approximate value? It is 1 by 4 pi into 1 by 36 pi into 10 raised to minus 9. So 4 pi cancels 9 times. So 9, when comes to numerator, it becomes 9 divided by 10 raised to minus 9, or 9 into 10 raised to 9. So according to this one, if one charge of 1 coulomb and another charge of 1 coulomb are kept at a distance of 1 meter away, think about 1 meter away, what will be the force? F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. So if this is the condition, this will be 9 into 10 raised to 9 into Q1 is 1 into 1 divided by 1 square, that will be 1 only. So that will be almost 10 raised to 10, that much newtons of force. Okay, so that is exactly 1 million ton. This is the weight of 1 million ton. So practically we don't have 1 coulomb charge, that much charge. If they are kept, this much force will be there. That is very high force. So practically the forces are, we know that the charge of electron is how much? 1 point E is equal to 1.602 into 10 raised to minus 19 coulombs. So in order to make 1 coulomb, we need almost 6 into 10 raised to 18. That is, after 6 you have to put 0, 0, 0, 18 zeros. So that many counts of electrons are required. Okay, so 1 coulomb is not practical. We will normally representing in nano coulombs or micro coulombs, like that. So this is about Coulomb's law in general form, or experimental law of Coulomb. Next we will discuss about how to represent Coulomb's law in a vector form. So Coulomb also mentioned in this one, F is proportional to Q1, F is proportional to Q2, F is proportional to 1 by r square, and he also mentioned one more thing, that the force has a direction. Force is a vector. It is acting from either in the direction of q1 to q2, or it will be from q2 to q1 based on the sign. If both are positive, the force will be repulsive. If both are negative also, the force will be repulsive. But if any one of them is positive and another one is negative, then the force will be attractive. So since we have the equation F is equal to 9 into 10 raised to 9, or 1 by 4 pi epsilon 0 q1 q2 divided by r square. So into, you have to introduce a unit vector in the direction of 1 to 2. Okay, so we will discuss that in detail. So consider this is the origin. There is a point 1 and another point 2. Okay, and the vector which connects origin and this one is called the position vector. We represent it as vector r1, and this is the vector which connects the position origin and 2.2, represented as r2, and the vector which connects first point to second. We discussed this one in the previous classes. It will be r2 minus r1, and the length we may write it as r. So the magnitude of length is r is r2 minus r1. So we assume that q1 is also positive, q2 is also positive. Then the direction of force, this repels this charge, and the direction of force will be in this direction. So we want a unit vector in this direction. So this is r12. So we want, so I can represent this as r12. Vector r12 is equal to r2 minus r1. This is magnitude r12. So we want a unit vector in the direction of a12. So that is represented as a12 cap. So complete description of Coulomb's law says that F is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r12 mod r12 square into a12 cap. Okay, or other words, we can write it as 1 by 4 pi epsilon 0 q1 q2 divided by mod of r2 minus r1 whole square into a12 cap. Now what is a12 cap? a12 cap is a unit vector in the direction of r12. a12 is a unit vector in the direction of r12. So how to get a unit vector in a given vector's direction? It is the vector divided by its magnitude. Correct? a12 cap. Okay, or otherwise I can write it as is equal to vector r2 minus r1 divided by mod r2 minus r1. So I will substitute that here. So we get 1 by 4 pi epsilon 0 q1 q2 divided by q1 q2 divided by r2 minus r1 square into vector r2 minus vector r1 divided by mod r2 minus r1. Together I can make this is square and into 1, so it becomes cube. So I can write it as F is equal to 1 by 4 pi epsilon 0 q1 q2 divided by mod r2 minus r1 cube into r2 minus r1. Okay, so this is how we represent the total force. So what we should know? We should know the value of this one, that is 9 into 10 raised to 9. Then q1 and q2 will be given. R2 is the position vector of the point where which q1 is kept. R2 is where q2 is kept. R1 is the position vector where q1 is kept, and this is the magnitude cube. So you have to find the square root first and then make it a cube. So this is the final expression for two charges. Okay. Now what if multiple charges are there? Okay, there are three charges. This is the origin. So I call this 1, this is 2, this is 3. Now we want a fourth charge which is kept here. So I want the force due to all the charges, or the force experienced by all these two. So it is like adding all the forces, vector sum of all the forces. So total force F total I can write is F14 plus F24 plus F34. Okay, so this is the force from 1 to 2, so we write it as F12. So this is F14, this is F24 plus F34. So since what is F14 here? So from this one I can directly write F14 is 1 by 4 pi epsilon 0. So q1 q2 divided by r2 minus r1 whole cube. Here I want 1 and 4. So instead of q1 it will be q1 only, and instead of q2 it is f14. So q4 divided by, instead of r2 minus r1 it will be r4 minus r1 whole cube into r4 minus r1, as simple as it is. Similarly, what is F24 then? F24 directly we can write 1 by 4 pi epsilon 0 q2 q4 divided by r4 minus r2 whole cube into r4 minus r2, and the last one F34 also similarly 1 by 4 pi epsilon 0 q4 or q3 q4 divided by r4 minus r3 whole cube mod whole cube into r3 minus r4 minus r3. Okay, so what if in the previous case from 1 to 2 what is the force we have found? So 1 to 2, what is F21? F21 is the force due to 2 on 1, it is in the other direction. So F21 will be minus F12, or it will be 1 by 4 pi epsilon q1 q2 divided by mod of r1 minus r2 whole cube. And if it is other way also this will be same, but here it is very important, r1 minus r2, it is not r2 minus r1. Okay, so that is what because we have a minus we interchange the direction. So these are the final expression for force. So this is Coulomb's law. Here we represent in vector form. So we'll see now two problems. Okay, we'll illustrate with the Coulomb's law for locating a charge of q1 is equal to 3 into 10 raised to minus 4 Coulomb at m 1, 2, 3, and another charge of q2 of minus 10 raised to minus 4 coulomb at n 2, 0, 5 in vacuum. Determine the force exerted on q2 by q1. So what we have to calculate is, there are two charges, one at 1, 2, 3 and another one at 2, 0, 5. So this is m, this is n. So here we have q1, here we have q2. So we want to calculate the force. So one of them is positive, another one is negative. So it will always attract this one towards this direction. So the sign of the force will be negative in the answer. Okay, that is the direction. But what we have to calculate here, the force of on q2 by q1. So what we have to calculate is F12. Okay, so F12 will be, the force magnitude will be negative because it is in the, so the direction will be negative. So what we have to calculate is F12. Okay, so we have the equation. What is the equation? F12. So what is F12? F12 is equal to 1 by 4 pi epsilon 0 q1 q2 divided by mod r2 minus r1 whole cube into r2 minus r1. Okay, so we have to find the value of r1. R1 is the unit vector, position vector of the charge q1. So what is q1? Q1 is at 1, 2, 3. So I can write r1 is equal to 1 ax cap plus 2 ay cap plus 3 az cap. Okay, what is r2? R2 is equal to the unit vector of point, the position vector of the point 2. So that is 2, 0, 5. So I can write it 2 ax cap plus 0 ay cap plus 5 az cap. So what is r2 minus r1? So r2 minus r1 will be 2 minus 1, that is ax cap, 0 minus 2, that will be minus 2 ay cap, 5 minus 3, that is 2 az cap. So what is mod r2 minus r1? Is magnitude of x square plus y square plus z square, that is 1 square plus 2 square, that is 4 plus 2 square, that is 4. So that will be 4 plus 4 8 plus 1 9. Root of 9 will be 3. Now it is plus or minus 3. Since we want only the absolute value or the distance as the measure, it will be positive value will be considered. So from this we can substitute the value of F12 as F12 is equal to 9 into 10 raised to 9, that is 1 by 4 pi epsilon. Q1 is 3 into 10 raised to minus 4 into minus 10 raised to minus 4 into r2 minus r1 is ax cap minus 2 ay cap plus 2 az cap divided by 3. So if we cancel all those values, divided by, we have r square is there, r cube is there, so that will be 3 into 3 into 3 into 3 where one of the 3 cancels with this 9 cancels with this one. So what you have is what left on the, so this will be, okay, sorry, it should be some mistake is there. Here it is, yeah, it is into here 3 cube it should be, so it cancels everything. Sorry for the confusion. So I will erase this one. Okay, so what is F12? F12 is equal to 1 by 4 by 9 into 10 raised to 9. Q1 is 3 into 10 raised to minus 4. This is minus 10 raised to minus 4 divided by R2 minus R1 is 3 cube. So 3 cube into AX minus AY 2AY plus 2AZ. So this everything cancels with the 9 and 3. So 9, 10. So it will be 10 into AX cap minus 2AY cap plus 2AZ cap. So this is the vector force acting at a point, force from 1 to 2. So there is this is the attractive force, since one of them is positive, another one is negative. If these both are positive, if this is plus, then this magnitude will, okay, so there is minus 10 is there. If this is positive, this minus 10 won't be there, it will become plus 10. Okay, so that is the value. We'll see one more problem where more than one charges are there. For example, 1 nanocoulomb, another 2 nanocoulomb, and there is one more 3 nanocoulomb is kept at a points. For example, corners of a let me put here, it is in the z plane at z is equal to constant plane, corners of a square of 8 centimeter, and this is at origin. Okay, so what is the coordinate of this one? It will be 8 comma 0 comma 0. So we have to calculate, sometime it may not be given. So what is this? This one, this will be, yeah, 8 comma 8 comma 0, and this is 0 comma 8 comma 0. Now what is the force due to, so this is 0 comma 0. Okay, what is the force due to all these charges which is kept at somewhere 4 comma 9 comma 0. Okay, so how to calculate? So this is 1, this is 2, this is 3, this is 4, this is 5. So what we have to calculate is F5, that is the force on 5, is given by F15 plus F25 plus F35 plus F45. So what is the value of F15? So F15 is 9 into 10 raised to 9. Let it be this one, some 2 nanocoulomb. This is also 2 nanocoulomb, and this is 3 nanocoulomb. So F15 is 1, that is 2 nano into 3 nano divided by R5 minus r1 mod of that whole cube into r5 minus r1. Okay, so I will do this one. Rest of the things you can try and add all those things. So what is r5 here? So r5 is 4ax cap plus 9ay cap, and r1 is 0, vector 0. So subtracting r5 minus r1 will be 4ax cap plus 9ay cap, and mod of r5 minus r1 will be square root of 16 plus 36, so root 52. So this will be 9 into 10 raised to 9 into 2 into 10 raised to minus 9, because nano is 10 raised to minus 9, 3 into 10 raised to minus 9 divided by root 52 cube into 4ax cap plus 9ay cap. So this is the value. So you can find all these values and add them together. So I am asking you to do this problem as homework. Complete the problem. Okay, that's all for today's class. Thank you.